Good morning, students. So today we can discuss about signaling systems in railway. Okay. So in the last lectures we have discussed about the signals in railway system, and the main objective of signaling is to control the movement of trains to have maximum safety by preventing accidents. So in order to achieve this goal, a particular system of working should be adopted such that it has to achieve three important aspects like safety, speed and traffic density of operation. Okay, so there are so many signaling system like absolute block system, space interval system, time interval system, pilot guard system, and the first method of signaling system was one engine only system, then developed time interval system, then pilot guard system, then train staff and ticket system, like that. Okay, and this absolute block system is the extensively used signaling system on Indian railways and also in other railway system also. Okay, so here in absolute block system, the railway track is usually divided into different block sections. Okay, so we can discuss one by one. First one is time interval system. And here the trains are spaced over a length of a track such that if the first train stops, the following train driver should be able to stop the train in sufficient distance without colliding with the first one. That is, if a train is moving on a track and so many other trains are following the train. Okay, and if the first train stops, the drivers on the previous train should be able to stop his train such that there should be minimum distance between these two trains. Okay, such that there should not be any collision between two trains. That is known as time interval system. That is, there should be sufficient time between the trains which is moving in the same direction or in the same track, such that there should not be any collision between these two trains. Okay, that is, trains are spaced over a length of a track in such a way that if the first train stops, the following train driver should be able to stop the train in sufficient distance without colliding with the first one. Okay, there should be sufficient space between these two trains, and this type is used where traffic is less and weight of the train are less. That is, example, trams. In these situations we are adopting time interval method of signaling, and this type of system cannot be used in passenger rail since the weight and traffic is very high. Okay, so this cannot be used in passenger rails because here weight and traffic is high. So in if there is traffic density is very low, this time interval method is used. This is one of the ancient method of signaling system. Okay, next method is space interval method. So in this method also the length of the track is divided into sections and is known as blocks, and the entry of train into the block is controlled in such a way that only when it is free the train can be allowed to enter it. That is, when the block is free only the train can enter that block. Okay, so that is known as space interval method. This also a miniature form of absolute block system. Okay, and this means that between two consecutive trains there is definite space interval. That is known as space interval method. And next is absolute block system, and this is the most commonly used signaling system in India, so it's very important. Okay, this system involves dividing the entire length of the track into sections. That is known as block section. So the entire railway track is divided into different sections, and that section is known as block section. And a block section lies between two stations that are provided with block instruments. That is, in between this block section there will be block stations. Okay, so here the entire railway track is divided into block sections, and in between two block sections there will be station. Okay, so the station is dividing the block sections. So there will be block section, next station section, then again block section, then station section, then again block section. Like that our railway track is divided into different blocks. And the block instruments of adjoining stations are connected through railway lines. The adjoining stations will be having block instruments, and these instruments of adjoining stations will be connected through railway lines. There will be communication between the station masters of adjacent railway stations. And a token can be taken from the block instrument of a particular station with consent of both the station masters. That is, if a train is entering into any railway station, the station master of the previous station should have communication between the station on which the train is entering. So a token should be created from the block instrument of a particular station with the consent of both the station masters. So when the token is given to the driver of the train, it can enter that particular railway station. Okay, so I will explain it later. So this is the system of absolute block. And in absolute block system, the departure of a train from one station to another is not permitted until and unless the previous train has completely arrived at the next station. That is, if the previous train is arrived on the next station only, the next train is allowed to enter into that block section. That is, trains are not permitted to enter the section between two stations at the same time. Okay, that is, there should be sufficient space. At that time only the train is allowed to enter on that particular station. And each station has two block instruments, one for the station ahead and the other for previous station, and these are electrically connected. The block instruments of each station will be electrically connected. So this is absolute block system. That is, as I have told, the railway track is divided into different block section, and the station section is dividing the block sections. Okay, so from the control room, the controller of train inform the station master at B to receive a train approaching from A. That is, a train is approaching from this direction, from A. So the controller of the train inform the station master at B to receive the train which is approaching from A. Okay, so that is the first step. And the station master at B, through verbal exchange, and if both of them agree, they will operate the block instruments. That is, A will operate his instrument and B, the station master at A, will operate his instrument, and B will operate his instrument. And the cooperative operation of these two instruments, which are connected electrically, will give a token to A instrument. And both the instrument become inoperable for any other token. That is, there will be a creation of token at A instrument, and a station master informs that the train is able to enter into the block section B. Okay, so the man will set the point and lower the signal for off position for dispatching the train. Like that, there will be arrangement. Okay, and the token which is taken out from the instrument at A is handed over to the driver as an authority to enter the section AB. That is, if a token if a token is produced at the instrument at A, it will be given to the driver, and when he receives the token only, he will be able to enter into this block section. Okay, so there will be communication between the station masters to check whether the section is free, or the station section is free to enter our train. Okay, and the train starts moving into the block section AB. And now station master at B, through the verbal exchange, that is, there will be telephone communication, and will discuss with the station master at C. And they operate the block instruments as in the previous one, and then simultaneously a token will be come out at B instrument. Okay, so as before, the station master at B will order his cabin crews to set the points and bring the signals in off position. Then after the arrival of the train, the points and signals are restored. And the driver of the train hands over the token to the station master at B, and he will insert this token to make the instrument in normal position. And the station master at B inform his cabin crew to dispatch the train and hand over the token for the block section BC. Okay, BC to the driver for departure. and the train enters the block section BC. That is, until the driver receives the token, he cannot enter the block section, and the token is produced by checking whether the station is clear for entry of the train. Okay, so this is the procedure of absolute block system. Okay, so this is most commonly method. This is absolute block system. So here the entire railway track is divided into different block sections, and there will be station section in between the block station. Okay, and the train will be able to enter any block section or any station section until the train will reach on the next station. Okay, so if the area is clear for entry of the train, a token will be produced produced by the station master, and it will be handed over to the driver, and then only the driver can enter into that particular station. Okay, so this is absolute block system. Then next, so this is also a figure which is showing absolute block system. That is, here the signal is green, so the train is able to enter here, but here the signal is red. That is, the train cannot move into this section because here there is a train. So when this train enters this section, so here it is green signal. So when this train enters into this section only, it will become red. Sorry, it will become green, and this train can move this section. Okay, so this is absolute block system. Next is automatic block system. So this is an advancement of our previous absolute block system. So this train here, the train can itself notice the clearance of the path, and so it will decrease the manual error. Okay, so here the section between two stations is divided into number of blocks, and electrical current is conveyed through electric circuit track, and when a train enters into a particular block, the electric current puts the signal at danger position. That is, there will be a red light, okay, for a particular block until the train has gone nearly 2 blocks ahead. That is for adequate distance. So if there is an adequate distance, that is, if the train pass or 2 block section only, the other train is allowed to enter into particular block section. Okay, so here the movement of the train is controlled by a stop signal and is operated automatically by the passage of trains past the signals. Okay, so here the all are controlled automatically. There is no manual effort taken as our previous method. That is, in the previous method the station masters are operating to enter the train, but here all systems are controlled automatically. Okay, so I will explain the working procedure. That is, here in this system 3 aspects of color signals are there, and it is yellow, red and green. Okay, so here colored signals are used, and so in this figure there is block section 1, block section 2 and block section 3. So train is moving in this direction. So before entering any section, all the signal lights in normal conditions are green. That is, in normal condition the signal is in green color. Okay, so when the train enters the first block section, that is in block section 1, the signals are actuated and the green light at A disappears. That is, when the train enters into the block section, this green light at this section will turns to red light, and the red light appears automatically. That is, this change of this color, the light is automatically controlled. That is, when the train is moving in this direction, here it will be green. So when it is green signal, the train is allowed to enter in block section 1. So when the train enters into block section 1, this signal automatically turns to red, because no other train is entered into this section, because there is already a train. Okay, so when the train enters the first block section, that is block section 1, the signals are actuated and the green light at A disappears and the red light appears automatically. Okay, thus this red light indicates there is prohibition of entrance of a train in block section 1, because there is already one train. Okay, and when this train enters into block section 2, what will happen? The green signal at B turns to red light, and red light at A will turn to yellow light. Okay, that is, when the train enters into block section 2, this signal here when it is entering into block section, it will be green, and when it enters into the block section 2, the green will be turned to red automatically, and the signal here it is in here it was red signal, and this red signal is turned to yellow signal. Okay, and this all transformation is controlled automatically. Okay, and these lights now indicate that another train cannot enter the block section. That is here it is red because there is no the entrance of other train is prohibited, and the train can enter block section 1 cautionly at a low speed since it is yellow. Here it is yellow because the train can enter into this block section 1 cautionly at a low speed as yellow light is at A. So this is the situation when the train is at block section 2. Okay, so this figure shows this indication, this color indication shows the train is in block section 2. So when the train is in block section 2, here there will be a red light because no other train is allowed to enter into block section 2. And here it is yellow because the train can move cautionly into the block section 1. And here it is green because this train can enter into block section 3. So when the train will enter the block section 3, when it enters into the block section 3, the green light at C will be turned into red light, and red light at B will be turned to yellow, and the yellow light at A will be turned into our normal light that is green light. Okay. So this is the process, or this is the method of operation of automatic block system. So here the change of light is controlled automatically, and that is it is connected by electric circuit, electric current. So this is about automatic signal. So due to this automatic signaling, human error is eliminated. So there will be greater safety and efficiency, and less number of personnel for operating the signals is required. So it will be so the operating cost will be low. So increased efficiency will be there, and here now block instruments are required. So these are some advantages of automatic signaling. Okay. So these are the different signal control systems. So this absolute block system is very important. So this is most commonly used one. And this automatic system is the advanced version of the absolute block system, and here all the control of signals are done automatically. Okay, so these are the different signal systems. So you should read the textbook. So if you have any doubt, please contact. Thank you.